This is Geometry, Chapter 15, Lesson 2, on page 628. All right, this lesson is specifically on rectangular solids. A rectangular solid is a polyhedron. In fact, when you have a shape bounded by planes, it is called a polyhedron. As long as where those planes intersect, they intersect in a line. All right, so look at the definition of a polyhedron. It's a solid bounded by intersecting planes. And planes intersect at a line. Planes intersect at a line. That's right. So a polyhedron is a solid that exists in 3 dimensions only. And it literally is these planes that are bounded. It's bounded by all these planes that intersect at lines. All right? All right, so look, let's talk about this. There are faces, edges, and vertices. The faces are the planes. Like a face is ADEH. Do you see that? ADEH? That is a face. The edges are where the planes intersect. Like DH, EH. You see that? The vertices, okay, the edges are where 2 planes intersect. In a rectangular solid, like a vertices is like D. How many planes intersect at the vertex? 3 planes intersect at the vertex. Do you see that? All right. Look at the definition of a rectangular solid. It's a polyhedron, and all of its faces are rectangular. How many faces does a rectangular solid have? Can you see them? Do you see them? There's 6. Yeah. Name them. So David, name a face.
DCGH.
DCGH. Okay, exactly. Name another one. Keep going.
ADHE. BFEA.
Yeah.
BADC.
Yep.
FEHG. BCFG.
Do you see skew lines
Yeah.
that are neither parallel?
Yes.
Okay. Do you see parallel planes?
Yes.
What is true about the planes in a rectangular solid?
The planes opposite them are parallel.
So how many sets of parallel planes?
4. 3. Sorry, she's right. I was
3.
thinking 8. I was thinking 8 faces.
3 sets of parallel planes, right? All right. So I want us to look at opposite vertices. Vertices that are not opposite lie on the same plane, like this plane ADHE. Opposite vertices would be A and H. But when we're talking about a solid, opposite vertices do not lie on the same plane. It's more like A and G. A is in the top left, G is in the bottom, the back right. Those are opposite vertices, A and G. What would be another opposite vertices? Here. Which one? C and E. Name another. B and H, and one more. D and F. Those are all opposite vertices. All right. Abby graciously drew this image on the board. Abby, it's much better than me. All right, if I wanted to know the length of AH, could I calculate it? How would I calculate it?
The Pythagorean Theorem.
The Pythagorean Theorem. So what would that be?
A squared.
8 squared plus 4 squared equals
C squared.
C squared.
Or AH squared.
Equals AH squared.
You were close.
Yeah, exactly. Right? All right. That's when you have opposite vertices on the same plane. When you have opposite vertices on different planes, it's the same, except now we have 3 values. So this straw or stick, the base of it is at E, but the top of it is at C. Yes?
Would it be 10?
Well, it's
No.
going to be,
Yeah, wouldn't
it's going to
AH
be
10?
8 squared
64.
plus 4 squared
36.
plus 3 squared equals EC
Oh, we're trying
squared.
to find EC, not.
So when we have opposite vertices in a solid, we have 3 dimensions that we're squaring. But do you see the connection to the Pythagorean theorem?
So we would add in those 3 squared.
Oh, I did something.
Yes.
So
Yes. So it's
Write
the
that out.
length. Look at the formula. It's theorem 79. The length of a diagonal of a rectangular solid is the square root of the length squared plus the height squared plus the width squared.
What is that the formula for?
The length of a diagonal of a solid. So it would be, in this case, EG squared, that diagonal in the solid would be the 8 squared plus the 4 squared plus the 3 squared. But to get the length of EG, we just take the square root of both sides. All right, so let's do this. The length of EG is the square root. 8 squared is?
64.
4 squared?
16.
3 squared? 64 and 16?
80,
And 9?
89.
So EG,
Equals the square root of 89.
89. Yeah, square root of 89. Can we simplify that?
No.
Does 9 go in? Does a perfect square? Does 4 go into it? No. Does 9?
Oh, no.
Hold on.
8.
I feel like something.
Does 16?
It's 21. Wait.
I'm going in perfect square. 16 is a perfect square.
I got square root of 89.
Square root of 89. That's it. Square root of 89. All right. So, what if instead this, okay, what if this were, I'm never going to be able to do this. Okay, we're going to try to do this.
I'll draw.
Oh.
What? Okay, it's not too bad.
Don't you want to make that outside line
I don't know.
It's good in your heart.
Okay,
It's good.
okay. But this would be what would this be? Is it a rectangular solid?
9, the square root of 9 plus 9 plus
Is it a rectangular solid?
Yes.
Is it a particular type of rectangular solid?
Just square.
equilateral.
It's a cube! It's a cube!
Is it
It's a cube! It is! Abby, in your imagination, it's a cube.
in your
Maybe
heart?
not visually, but in your imagination,
Think
it's a
with your
cube.
brain,
Yeah.
not your
Think
heart.
with your imagination, right?
Other
Wait,
way.
other way.
Okay, so what would my diagonal be?
It's 3 plus 3 plus
that
3 squared plus 3
diagonal
squared plus 3 squared.
would be the square root, which is an edge, would be 3 squared plus 3 squared plus 3 squared.
27, square root of 27.
So it would be the square root of 27.
And 9 goes into that.
That's correct. So 9 goes into that, so it would be what?
3 times square root of 27, or would it be 2? Yeah, 3.
I got shade of 3 squared. 3 squared.
3 squared of 3. Yes. Okay, what does 3 represent? The length of the edge. I should make this the diagonal. Diagonal. I'm not going to put distance. Diagonal. Diagonal. So if you have a cube, this pattern always works.
It's always going to be.
It's the length of the edge times the square root of 3. Always.
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 Forever.
Always. Okay, let's change it. Let's make, I don't know, let's just make this 6. We'll make it 6. Let's make it 5, not something even, okay? Let's make it 5.
3's not even.
You're right. Let's make it even. What number do you want it to be, Dad? 4. Let's go to 4. Let's go to even. 4, 4, 4. All right. So what would it be? It would be the square root of 4 squared plus 4 squared plus 4 squared. What are we expecting the
16.
answer to be? What are you expecting the answer to be?
4 square root of 3.
Okay.
4 squared root of
4 squared is
The math teacher was right.
16 plus 16 plus 16. What's 16 times 3? It's 32. No.
That's times 2.
48.
No, that's 18 times 3.
3. No, it's 48.
16.
48. Square root of 48. What's a perfect square that goes into there?
Wait.
16.
Yeah.
Yeah.
How many times does 16 go into there?
3.
So it's the square root of 16 times 3. You agree?
Yes.
That's the same thing as the square root of 16 times the square root of 3.
Yes.
Okay, what's the square root of 16?
4.
4 square root of 3.
Math is useless.
Yeah. All right.
That's algebra, right?
That is algebra. Yeah.